Hi there. If you're having a hard time with data structure stuff, please keep watching. This video is for people who are new to programming and know JavaScript. You're self-taught, you have no computer science background, and you're trying to prepare for interviews and linked list came up and you're wondering, what is this? Okay, so let's take a look here. This is a picture of a linked list. As you can see, like all data structures, like arrays and objects, it stores some type of data, but it has something next to it called a next. And that points to another thing over here called a node. So let's learn about what those things are. Here we go. Hold up. If you're like me, you're probably wondering, why the heck should I use a linked list? We have arrays and objects, and I've used those things, and it seems like everyone else uses those things to make stuff. Well, to understand why linked lists were created, why they were used, and why they're not really used anymore, we have to understand how things are stored in a computer's memory. Things are stored on a computer's memory using random access memory, or RAM. This is what RAM looks like in your computer. Each bracket represents 1 byte, and 1 byte holds 8 bits. A bit is used to represent 0 or 1 in binary. Let's use an example to explain. In JavaScript, you can actually use this line of code to check how many bytes are in a variable. So a string of string has 6 bytes. Five fives has 3 bytes. Okay, so let's store string in the variable x. The binary for string is 6 bytes, and each byte has 8 bits. So this byte and its binary represents S, and so on and so forth. This one represents T. So what actually happens here in the computer's memory, JavaScript points this X to these memory locations. It's a pointer in memory, and each one of these represents a character, and it keeps going through all the characters until it hits null. And null represents the end. And that's when JavaScript interprets these binary numbers and turns them into the characters string. Now it's time to go back to linked lists and talk about why they were invented and why they were used. So our example here, let's use an array and let's put this array in memory. Let's actually make this a array of 1 to 3, so 3 indexes. So here we go, 1, 2, 3, and I'll remove the spaces to indicate that it's an array. And let's put a null here to indicate the end of this array. Now, as you're writing a program, you're going to have other variables, maybe x and maybe y. Those also need to go into our computer's memory, so the computer is going to put them here and here. Okay, well, later in our program, maybe we want to add a 4 to our array. Oh no, look what just happened. Well, we have our array of 1, 2, 3 here, but we have our x right next to it, and there's no memory location to add the 4. The 4 has nowhere to go. We can either erase the x, which would explode our program, or we have to do a long process of adding all of these numbers in and recreating a new array with the correct numbers in it. And as you can imagine, that's a lot more steps in our computer's processor than just simply doing 4 on the end of our old array. So we have to add the entire array in memory again, and we also have to remove the old array too, because it's not going to be used anymore. It's a waste of memory to keep it there, and that's called memory cleanup. Therein lies the problem that linked lists were invented to solve. That is, we don't have memory locations where we need them, right? So a linked list solves this problem by doing something clever. Instead of just storing a value, so let's say we wanted to create a linked list with the value 1, it stores a value of 1, and it stores something called a pointer. And a pointer simply points to a location in memory for the next part of this linked list. And by default, a pointer won't point to anything. It will simply point to null. When you create a linked list, you're going to tell it the value and the pointer. So let's go through our example again. Now we have the variables x and y, and those are also stored in memory. But now we want to add 2 to our linked list. Let's see how we do that. Okay, well, since it's a linked list, we can just put a new node here, and each part of the linked list is called a node. This is the first node, called the head. This is the second node, where we're going to store 2. So let's put 2 here, and let's create a new pointer, and it's going to point to null. So pn. What we're going to do now is just simply update this pointer so it points to the node 2, and we'll call that an object, because in JavaScript, each node is an object. And to represent that, let's just draw an arrow. This points right here to our second node. So the cool thing is now that we have this system of pointers, we can actually store the next value in our linked list anywhere we want in memory, which is totally awesome. So check this out. Let's add a 3 here. Now we can put this 3 anywhere. Let's just put it over here. So we'll create a new node. We'll put 3 here, and we'll add a new pointer, which points to null. And all we have to do is update this pointer to point to 3, and we'll draw our arrow down here to the new node. Now we have another node in our linked list, which holds another value. Okay, here are some key takeaways about linked lists. First of all, normal variables have only one pointer, and that pointer points to the variable's value in memory. But linked lists have 2 pointers. One points to its value, and the other is reserved for a pointer to its next value in memory. All right, the question that answers everything about linked lists: why aren't linked lists used anymore? Well, that's because RAM, the hardware we used to store stuff on, has gotten much more powerful and cheap. So we don't have to optimize our storage as much as we did in the past. Also, JavaScript is smart and it allocates extra storage space after our array in case we want to add values to that array. And if that array runs out of space, it will automatically delete that array and create a new array, again, that's bigger, and it will add more storage space after that array in case it still needs to get bigger. Thank you so much for watching. I hope I was able to help you learn something new. If you want to learn more about linked lists and how to use them in JavaScript, for example, on solving algorithms, please see my next video. And if you have any questions, please leave them in the comments below and I will do my best to help you. Thank you.